All right, so let's go ahead and finish this up. So we're going to finish this up by doing the significance testing. Significance testing. So if you look at the significance testing, as you would expect, there are conditions there, and the conditions as you expect are the same as your confidence intervals. The same three things: random sample, cannot oversample, less than 10%, and also the large counts. Okay. Then you flip the page, and the test statistic you're going to use is what you would expect. It is this guy minus 0 over, so this is T star, right? It's going to be equal to your S diff over square root of n. Okay, this is the test statistic you will use to find the T star, and then you would go into the list and find out what percentage or what your p-value is. Okay? So, if you go to page 680, there is a caffeine independence test example there. And let's see, let's pick on Cat. Read this for us.
Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which subjects took caffeine and placebo was randomized. At the end of each 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. The table.
Yeah, we're good. So the table, you have the table there. And it says, do the data provide convincing evidence? And we're going to do a significance testing with an alpha level of 0.05. Okay? So, first of all, do we have paired data? What makes this paired data? Anybody?
It is paired data, right?
Yeah, it's paired data, right? Because you're using the same person, right? You're measuring two different things, or the same quantitative thing, but under two different conditions, but using the same person, right? Okay. So yes, we do indeed have a situation where it is paired data. Okay. So what's the very first thing we're supposed to do when we're told that when it's a paired data, the very first thing we do is we go ahead and subtract and find the difference, right? We're going to look at the differences, right? So if we look at the differences, what do we get? So we're going to have the caffeine. So we're gonna subtract, right? So we're going to do the placebo minus the caffeine. Okay, you're going to do the placebo minus the caffeine. Okay, so your data set is actually going to look like what? You're going to have 11, 18, 1, 4, 6, 19, 6, 3, 13, 1, and -1. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so let's look at the data here. Do we have something going on here? What do you think? This is the difference here. Do you see anything there? Is there something going on?
There is something going on.
There is something going on, right? All the numbers are positive. Some are pretty large, except for this one guy, and it's only -1, right? So definitely, you're right. Definitely, you're going to have more depression when you have the placebo. Okay, so actually, that kind of says to ourselves, okay, maybe we should test this, right? So let's go ahead and state. We're going to state, and we're going to say the X diff, okay, is 0 would be our HO, right? our how would be that our x diff would be what? Greater than 0, right? We think it's going to be greater than 0, correct? Looking at the data here, right? So when our alpha is going to be 0.05, right? So this is our state, correct? What's our plan?
You have
What?
to test if it's random, if it's 10%, and then if it's large or normal.
So it's random. We're told it's random, and there are many people who frequently drink coffee more than 110, I'm assuming, right? So we're obviously going to be less than 10% there, okay? And are we a normal distribution? Or are we greater than n is equal to greater than 30? Neither one is true here, correct? We don't know if it's normal distributed or not. We definitely know that n is less than 30. So we're going to go ahead and do a dot plot, or over here, I guess the book did a histogram. We look at a histogram, and it doesn't look like there's any skewness there. It looks kind of roughly, roughly symmetric there. Okay. So like the book says, there's no strong skewness or outlier. So we're going to go ahead and say the large count is satisfied. Okay. So what's the next thing to do? We're going to do it, right? So let's do it. So we're going to do this, and we're going to find here from this data set that x diff and s diff were what? X diff was 7.364, standard deviation of 6.918, 6.918. So let's go ahead and now calculate our, how do we find the t star? Where are we going to find the t star? T star is equal to x diff minus 0 over s diff square root of n. So we're going to get 7.364 over 6.918 square root of 11 or 12. Is it 11? 12? 11. Right? If I calculate this, I am going to get 3.53. So now we go back to our table, T-3. If you go back to the table on T-3, what is my degree of freedoms here? Lauren.
Wouldn't it be 10?
Degree of freedom would be 10. So we go over to the book, and degree of freedom is 10. And we're trying to find 3.53. If you look at 3.53, it is in between what? It's in between 0.005 and 0.0025. Okay? So your p-value is going to be between 0.005 and 0.0025. If you do the TCDF, you actually find it to be 0.0027. Either way, we know that it's going to be less than the 5%, correct? So we know that it's going to be less than the 5%. So the p-value is less than the alpha, which means that we're what? What are we doing here? Alia.
The hoe.
Alia, what are we doing?
Reject the hoe.
We're going to reject the hoe. We have convincing evidence that the high is true, right? Okay, so we're good to go. One thing I want you guys to do on page 683, there's an example there, and I want you guys to read this on your own, okay? There's an example on page 683 which goes through identifying whether it's paired data or not, okay? Because this doesn't happen that often. So you need to be able to notice it when it does happen, okay? So there's an example there that gives that it has 3 separate things. I want you to go ahead and read that on your own. And we are going to call this done. Okay, so it looks like I have